Okay, let's just dive right into this explainer and demystify the exact mechanics behind your most frustrating login tickets. If you've ever found yourself staring blankly at a failed authentication log, well, you're definitely in the right place.
Because as IT support engineers, we see this literally all the time. You know the drill. Users are complaining they're locked out, integrations are silently failing in the background, and you're left looking at massive, terrifying error logs that seem to offer zero actual help. So we're going to break down exactly what's happening under the hood until it all makes perfect sense.
Here's our roadmap for today. We'll start with what OAuth 2.0 actually is, look at the authorization code flow, break down tokens and scopes, and finally, walk through a real-world scenario of fixing refresh tokens.
So Section 1, what is OAuth 2.0?
Think back to the old days. If a third-party app wanted to access, say, your calendar, you had to hand over your actual password. Terrifying, right? Well, OAuth 2.0 completely changed the game. It's kind of like checking into a hotel. Instead of the front desk handing you the master keys to the entire building, they issue you a temporary keycard that only opens specific doors, and only for a limited amount of time.
Fundamentally, OAuth is an open framework all about authorization. It answers the crucial question, what exactly can this app access, rather than just authentication, which really only answers, who is this user? It lets you safely delegate access so those third-party apps can act on a user's behalf without ever seeing their password.
Moving right along to Section 2, the authorization code flow.
This whole process kicks off in the front channel, meaning right there in the user's browser. First, a user clicks Login in your app. The browser immediately redirects them over to the authorization server, like Google or Microsoft, and passes along a special code challenge. The user logs in there, and they're hit with that familiar consent screen. Do you want to allow this app to access your data? Once they hit approve, the magic starts.
Now you might be wondering, since the user just authenticated right there, why don't we just hand the access token directly back to the browser? Well, exposing highly privileged access tokens in browser URLs or redirects is a massive security risk. Anyone intercepting that browser traffic could literally steal the keys to the kingdom. No way we're doing that.
So, instead of sending the token directly, the server returns a temporary single-use authorization code back to the browser. Your application takes that temporary code and exchanges it completely behind the scenes on a highly secure server-to-server backchannel. Because this backchannel communication is totally hidden from the browser and requires your application's private secret, it's incredibly secure. And that is where your app finally gets the actual tokens.
Which brings us to Section 3, Tokens and Scopes Explained.
Notice how our credentials are very cleanly separated here. First, we have the access token. This is short-lived, we're talking maybe minutes to hours, and it's used to make the actual API calls. Then we have the refresh token. This one is long-lived, lasting days or even months, and its entire job is to silently obtain new access tokens when the old ones expire. And finally, the scope. This isn't a token, but rather it dictates the exact specific permissions those tokens actually hold, like read-only access, for example.
Now this brings us to a universally relatable support scenario. Imagine a user opens a ticket complaining, hey, I keep getting logged out. They reconnect their integration, it works perfectly for exactly an hour, and then it just breaks again. So, what exactly is going on here?
Let's tackle this in Section 4, Scenario, Fixing Refresh Tokens.
When you dig into the application logs for this user, right at that 1-hour mark when their access token expired, you're almost definitely going to see this terrifying catch-all error block, invalid_grant. All this really means is that the authorization grant you provided, in this specific case the refresh token, is no longer valid. The server just flat out rejected it.
The real problem is that this single error string is a totally miserable catch-all. It blends user actions, provider policies, and client bugs into one single label. It could mean the token actually expired, maybe you reused the single-use code, perhaps your redirect URI didn't match byte for byte, or even that your server's clock is just a few seconds out of sync with the provider. It's on us to isolate the true cause.
Honestly, usually it's a provider policy causing the headache. SaaS providers have these undocumented quirks that can drive you crazy. For example, did you know Google will just randomly cut you off if a user connects too many demo clients, capping out at 50? Or if your Google app is in testing mode, those tokens just die after 7 days automatically. Salesforce will actually revoke the oldest token if a user simply connects more than 5 times. Microsoft revokes them after 90 days of inactivity. You really have to know your specific provider's rules.
So to diagnose this, let's walk through a quick demo in Postman. By manually recreating the post request to the token endpoint using that user's refresh token, we instantly get a 400 bad request with that invalid grant payload. This proves, without a doubt, that the token is absolutely dead. There's no back-end magic that's going to save you here. You need to immediately stop all automated retries, guide the user back to the front channel, have them click Login, and fully reauthorize the application from scratch to generate a brand new token family.
And this highlights the golden rule of OAuth troubleshooting. Treat invalid_grant as permanent, absolutely permanent. No amount of automated retrying is ever going to fix a revoked token. In fact, if you put an invalid_grant error on a hot retry loop in your background jobs, you definitely won't fix the login, but you will absolutely burn right through your API rate limit budget and probably get your app blocked entirely.
So, before you go escalating a ticket to Tier 3 or waking up a developer in the middle of the night, just run through this quick checklist. Make sure you aren't just dealing with a stray trailing slash on a redirect URI. Ensure authorization codes are absolutely never being reused. Check that your server clocks are perfectly synced via NTP. And lastly, verify you haven't just hit a silent provider quota or admin revocation policy.
I'm going to leave you with this provocative thought as we wrap up. As you resolve these tickets, take a really close look at your background sync jobs. Because if your refresh path isn't single flight per account, do you actually have a token system or just a massive race condition? Think about it. If two background processes try to refresh the exact same token at the exact same millisecond, the provider might issue a new token to the first process and instantly invalidate the token for the second process, completely breaking the integration behind your back. So definitely keep that in mind the next time you see an invalid_grant.